Hi, everybody. Welcome to Byte Ventures, where we deep dive into the marvels of technology. In today's case study, we'll discuss about scaling productivity on microservices at Lyft. So let's see what were the history of their infrastructure, what were the time when they onboarded the services as monolith or microservices. So till early 2018, they had all of their services written in PHP, and this monolith was serving most of their use cases. In late 2018, they decided that, okay, now it's time to break into microservices, and that's when they decided to break their PHP monolith into Python and Go microservices. As obviously, they got some obvious advantages with using microservices, like they could now experiment faster, they could deploy their services faster because each smaller team was working independently without any dependence for deployments on other teams. The code repository for each team was flexible in the programming language they can select, and the projects or the services have stricter or looser requirements based on whatever their service was responsible for doing. But when the microservices scaled, when they have onboarded more than 1,000 engineers and their services exploded to 100 plus services, they face some very obvious bottlenecks, and that led to a very difference of productivity for the developers. They thought, is there a better way? And that's when all of this thought process started, that how can we improve the productivity of the software developers working on various services at Lyft scale when they still have the microservices architecture in place. Okay, let's talk about development first. So around 2015, when most of their services were based out of the PHP monolith, some of the services like driver onboarding and all were still in microservice. That time they were onboarding around 100 engineers, and they thought like it's high time to move to a container specific architecture. And in 2015, the things like Docker desktop, Rancher desktop was not so much in popular. They were in very nascent stages. So they thought of like to build a container orchestration environment which will eventually scale their microservices pretty efficiently. It would be cheaper for them to run their multi-tenant services. And that is when they developed their first developer environment in a box, which is called the Devbox. Okay, let's just see what exactly is a Devbox. So Devbox was something which was developed around 2016, and they thought like, okay, it should be used in development environment first, and then if it works well, we'll eventually take it to production to manage our whole Docker images, because that they have planned it already. But it got suddenly very popular among the developers. So what exactly the Devbox did? So the Devbox managed a local virtual machine on behalf of the user, because they were planning Docker images and they are using Macs or Windows at that time. It was not very straightforward. So if you know about Docker a little bit, so Docker uses kernel level features to manage the containerization of applications. So if you're running on a Mac OS or a Windows machine, it was not very straightforward back then in 2015 to run a Docker container or Docker image on your local. So they had to use some kind of virtual machine for that. And this Devbox was responsible for managing the local VM on behalf of the user. So what exactly it did, it kind of installed or updated the packages that needed to run the service eventually. It configured the R unit to start services. So R unit is something to manage the processes and services. It's kind of like systemd or something, or if you're talking about very layman specific terms, think about supervisor, right? Supervisor is like, you want to run a process, you define its configurations, probably it manage all of their configurations in that case. The shared folders. So in some cases, one application might need to share the data across multiple applications, and that's when this concept of shared folders come into existence. They use this thing to share data from one to another application in this case. When the VM was up, it was very easy to run the whole thing. A single command pulled the latest image from the repository. It created the required database with creating the tables, the columns, required indexes, and all stuff, and created a Envoy proxy sidecar, which is used for routing requests into this. And as soon as this is done, which is done in probably a couple of minutes, the service is up and running wherever an external request can be directly hit into this. That was the seamless experience they built with Devbox. But with increasing requirements, there was something that needed their attention. So they have the requirement for a longer lived environment. Now that their system is mature enough, more people are using this service, they need to have this feature. And the other very important thing that came up while this was in production was the need to share the environment with others. For example, reviewing the design decisions. So if you have a PR and you are reviewing some designs across, then you need to probably share that environment. And that's when they thought like, okay, can we make something which is kind of Devbox but runs on the cloud? That's exactly when Onebox was introduced. So what exactly is Onebox? Let's see. So Devbox and Onebox are pretty close. So if you think about layman terminologies without getting into the depth, Onebox is like Devbox running in an EC2 instance. So Devbox was kind of like managing the virtual machine on behalf of the user, right? So we talked about Docker. So they thought about this, that they had like multiple services running, service A, service B. Probably these are two different microservices, and this is the Docker which was supporting all of this service. But there was not a very straightforward way because they were using Macs back then. And that's when they have to have a kind of Linux virtual machine with this. So Linux virtual machine was this, which is used internally by the Devbox. So this was everything present inside the local developer's computer. And as we know that this Docker inside a virtual machine eventually uses this driver's resources. Like if we have 16 gigs of RAM, then this virtual machine which is installed inside this MacBook cannot exceed 16 gigs of RAM, right? So there were kind of limitations on this. And when they move to a cloud instance with this, and this cloud provided Linux machines like Linux instances. So they don't need to have a virtual machine in here. So that's why you see that, okay, there are multiple services here, but there is no VMs here, right? So this Docker can now run directly because this is a virtual machine, and this was pretty much seamless. The adoption of Onebox was highly unexpected. It was like huge adoption of Onebox. People just went away from Devbox and everyone wanted to use Onebox because of its obvious advantages. The primary of them was the power. So Devbox was something that was running in the local machine of a developer. So that was constricted by the RAMs and the CPU of the machine that they were given. But this was running on the cloud, and this was running on the R3 4x large machines with 16 virtual CPUs and 122 gigabytes of RAM. So if you don't know about R3, so R3 is kind of instance provided by AWS, which is kind of memory intensive box. When you need a memory intensive process to run on it, they're pretty much optimized for that space. And 4x large is kind of a category. They have like 1x large, 2x large, 4x large, and probably 8x large. Okay, now that we have talked about their development structures, let's talk about integrations tests. One of the major things that Onebox did was make the allocation of resources pretty seamless, right? That means whenever someone wanted to spawn an instance, they just need to replicate the whole thing again and again. And integration test was almost the same thing behind the back, right? You need to give a service, list the dependencies, and want to tell that, okay, what all integration tests you want to run. And with the seamless integration of Onebox, things were pretty much easier. So what they did is like they developed something called as a manifest and .yaml, which looked something like this, which provided the name, the type of this, and it provided the dependencies. on this and the tests that needed to be run. So whenever someone wanted to run anything, they can just go ahead with this and run any of these integration tests without any problems. That led to huge adoptions of the integration test when everyone wanted to have this test running for their PRs. And that led to reduction of the local test or the unit test that people were writing earlier. Okay, coming back. Now that they have this test, they have this environment set up, they need to have some sort of place just before making sure that, okay, things are working fine right before production. That is the staging environment. So the staging environment at Lyft was very identical to prod, just that it didn't have the original data and the scale of the services running were pretty much smaller, but everything else was very closely replicated to that of prod. There was one problem for which staging was very effectively used, and that was for load testing. In certain festivals like Halloween or New Year or Thanksgiving, there are kind of very huge requests for ride-sharing services like Lyft or Uber. In those cases, people used to have a lot of requests coming into the server, and that would lead to huge outages in the system because that was very one-off cases that were not used to those kind of traffic. So in these cases, the team, what they did is they kind of use the staging environment to simulate those kind of situations where there are certain drivers or there are certain modules which was canceling the driver's acceptance rate, and there are certain modules which kind of generated a very high frequency request from a particular area. And that led to a lot of efficient management of their services because now they know that what are the points of failures, what are the services that need to be made much more efficient and stuff like that. These simulations played a very pivotal role because it eventually generated some very valuable data. And now that everyone wanted to consume this data because they wanted their services to be more resilient and all stuff. Okay, things are working fine, right? Everything looked seamless. The development was seamless. They were moved to Onebox. Now that they have their staging environment replicating high-end use cases, and they have this integration test running on each developer's features pilot or whatever they say it. Then what are the problems with this? When the staging environment was closely replicated to that of the production, the experiment took a very huge hit because the experiment started to break some other changes which were getting deployed on the staging environment. The second thing was, now that each service has a single instance on the staging, it was very difficult or it was not possible to have more than one change per service deployed on the staging. So it was like you have to process one change per service, and one after that feature is taken out, then you can deploy another change for that particular service. With things starting to getting used up, more people using the staging environment to test out their PRs, because now that they have kind of very simulated real traffic, the build times of all of the services got increased. By this time, there was another problem that got introduced. It was like 4 or 5 years down the line. We're talking about the time of 2020, when the production and the staging environment moved to K8 or the Kubernetes. But the development environment was still kind of following the older structure. And there were a lot of problems with that because now that some applications have moved themselves out of the staging environment, they have very, very big problems introduced because no one wants to maintain those kind of issues. If something breaks down, whose responsibility is that? And that leads to a huge question of ownership. Who owns what service? Someone who just spawned a Onebox cluster, or someone who actually knows the logic, or the developer infra team? And eventually it came to the on-calls of developer infra, which led to huge consumption of time because they didn't know anything about the application logic. They didn't know which configs to fix in order to make the application start. And that led to a lot of bottlenecks, a lot of hit to the developer productivity at Lyft. And last but not least is the bloats. So because the experimental feature, the CI pipelines were so smooth because of the introduction of Onebox. People were writing much more tests now, thinking that, okay, the existing test might be getting used for something, even if they're duplicating all of the tests. That led to a lot of bloating, and the transitive dependencies kind of grew a lot as well. These are some of the breaking points that led to a massive hit in the developer productivity. And that's when the team at Lyft thought about, okay, we need to have a solution so that we make our engineers effective and churn out high quality features as well. The first thing that came to their mind is the development environment, like staging or stuff, was getting too expensive with so many people onboarded. They realized that it is very high time to replace the Devbox, the Onebox, and the integration test running on the continuous integrations or CI. After much analysis, they found out that these were the three most important parts any developer would need to make the request reach production. First, they would run their service locally, doing some manual requests, which would do some kind of initial sanity test, whether that service is working or not. Then they will put it into a staging environment with the isolated traffic, so that they know that, okay, with isolated traffic, without anything, my service is working perfectly as expected. But this is not enough, and they would need some kind of automated acceptance test before moving things to production. And that would be done here in this part. And this is the whole structure of how they thought that this would increase the productivity of their users. And that is it. So in the next couple of videos, or in the next 3 parts of the videos, we'll dive deep into each of these parts. So part 2 will focus on this, part 3 will focus on this, and part 4 will focus on this. We'll find out what were the challenges they faced, what were the learnings, and how did they make sure that they provided top-notch feature publishing power to the developers without hitting their productivity at all. And yeah, let me know if you have any questions or feedbacks. I would love to answer them in the comment section. That's all for today. Have a nice day and see you in the next one. Thank you.